Welcome to BSc Statistics students. So in this class I explain statistical analysis of two-square factorial experiment. So what is the statistical analysis of two-square factorial experiments? You see here, we have learned all the points I have discussed in detail all the points of two-square factorial experiments. But we get the question in the two-square factorial experiment. The essay question is this only, is statistical analysis only. Now you see, the statistical analysis of this two-square factorial experiment, it is very similar to the CRD or RBD or LSD. Usually we conduct by using randomized block design RBD. That is what we use in general. RBD maximum we use randomized block design, except for the treatment effects, right? The treatment sum of squares is going to be split into the three orthogonal components, each component with 1 degree of freedom. That is already we have discussed. The orthogonal components, three orthogonal components, which are main effect A, main effect B, interaction effect AB. These are the three particular orthogonal components because we have proved that these three are orthogonal contrast, mutually orthogonal contrast, right? So therefore, which follows 1 degree of freedom, right? That is what we are specifying here. And the factorial effect totals, first of all, in the statistical analysis we calculate first of all factorial effect totals, which means we consider two particular factors at two levels, level 1 and first level and second level, that is level 1 and 2, for which the factorial effect totals A, B and AB. Factor A, that is main effect A, factor B, the main effect B, and interaction effect AB, for which the totals are going to be calculated, always to be considered as square bracket. Square bracket A is equal to square bracket AB minus B minus plus A minus 1. This is what the signs, it depends on the signs. What is the sign of A? A and AB. In A, it is plus. So that is you have to remember the signs of the respective treatments 1A, B, AB. That is what we have to consider. So therefore, AB minus B plus A minus 1, all are square brackets because totals. So these are the totals corresponding to AB, corresponding to B the treatment combination, corresponding to A the treatment combination, and 1 another treatment combination. So similarly B, AB plus B minus A minus 1, bracket square bracket AB, the total with respect to interaction effect AB, AB minus A minus B plus 1, all are with the square brackets, where 1A, B, AB are total yields of R units receiving the treatments 1A, B, AB respectively. The square bracket 1 is respectively for receiving the treatment 1 in the R experimental units, the yield, total yield. Similarly remaining. So therefore, now what you have to calculate sum of the squares next. You see, the sum of the squares due to any factorial effect is obtained by dividing the square of that effect total by 4R. What you have to do is we have to calculate the respective effect total and square it and divide it by 4R, which gives sum of the squares due to that particular effect. The sum of the squares due to any particular factorial total, factorial effect is going to be calculated by squaring and divided by 4R, which gives you sum of the squares due to the effect. Therefore, you see here, for example, sum of the squares due to the main effect A SSA, we denote SSA. The sum of the squares due to the main effect A is equal to A square bracket square bracket A, which means total yield. That is what we have obtained here. Bracket square bracket A. Total yield due to the effect A whole square divided by 4R. Similarly, sum of the squares due to the main effect B, SSB, is equal to sum of the squares due to the main effect B is equal to square bracket B, that is the total yield of the units, experimental units receiving the treatment, all the 4 treatments in the due to the effect B, that is B square divided by 4R. So these are the SSA, SSB. Now SSAB, that is due to the interaction effect AB. So due to the interaction effect AB, it is denoted by sum of the squares SSAB. Sum of the squares due to the interaction effect AB is equal to AB square divided by 4R. We have clearly defined AB. What is AB? AB is interaction effect AB, the total of the all the treatments by receiving the treatments, total yield of the or experimental units receiving the treatments 1A, B, AB due to the interaction effect AB. So that is it is denoted by square bracket AB and whole square divided by 4R. Each of these carries 1 degree of freedom. Sum of the squares due to the main effect A, due to the main effect B, due to the interaction effect AB, SSA, SSB, SSAB, which all carries 1 degree of freedom respectively. Right. Now this is what the ANOVA table of randomized block design, that is 2 square factorial experiment by using the randomized block design. You see, if you consider 2 square factorial experiment in randomized block design with R replicates, replicate means repetition of treatments. The following ANOVA table is going to be summarized in the 2 square factorial experimental design with how many replicates? R replicates. So this is not ANOVA table. At the end we have to show that this particular table, ANOVA table of 2 square factorial experiment in RBD with R replicates. This is what you have to write clearly. And so that what are the columns are required to write? Source of variation, degrees of freedom, sum of the squares SS, mean sum of squares MSS, variance ratio, that is F statistic, or we can also call F statistic. That is from the distribution of F it is going to be calculated. So source of variation, first one, blocks, replicates. Blocks indicates replicates, how many number of times we are repeating the treatment. That is for this R is the number of replicates. Degrees of freedom, R minus 1. Sum of the squares, SSR, and mean sum of the squares, it is not SA square, it is SR square. It is SR square. Okay. Then it is SSR by R minus 1. It is SR square, SSR by R minus 1. FR is equal to S square R by S square E. S square E will be the error. Sum of the squares due to the error. Here we will get the mean sum of squares due to the error is SSE. That is S square E. Mean sum of squares is S square E. That is going to be used here. FR is equal to, that is F ratio for the blocks or replicates. R is equal to S square R by S square E, which follows R minus 1 and 3 into R minus 1 degrees of freedom respectively for everything. I will tell you in the comparison conclusion. Main effect A, 1 degree of freedom. Already we have specified main effect of B, 1 degree of freedom. Interaction effect AB, 1 degree of freedom. So main effect A, degrees of freedom is 1. Sum of the squares is SSA is equal to A square by 4R. This is total square divided by 4r. Then mean sum of squares, s square a is equal to SSA. Then FA, that is F ratio for the main effect A is equal to S square A by S square E, which follows again R minus 1 and 3 into R minus 1 degrees of freedom respectively. And main effect B, 1, degrees of freedom is 1. Sum of the squares, SSB, B square by 4R, S square B, mean sum of squares, SSB, and variance ratio, FB, is equal to S square B by S square E. Again, same degrees of freedom. Interaction effect AB, interaction effect AB, degrees of freedom is 1, SSAB, sum of the squares, and it is equal to AB square by 4R, and mean sum of squares, S square AB is equal to SSAB, divided by degrees of freedom is 1 for these three, 1, 2, 3, divided by degrees of freedom. S square, that is mean sum of squares, is nothing but sum of the squares divided by degrees of freedom. You see the first one, SSR by R minus 1, SSA by 1, therefore SSA, SSB by 1, SSAB by 1, therefore S square AB is equal to SSAB. Right? FAB is equal to S square AB by S square E, which also follows same degrees of freedom. Next, error. Another important one, error. Error is degrees of freedom is 3 into R minus 1. And sum of the squares is SSE, it is going to be calculated by simple subtraction of total sum of squares minus SSR minus SSA minus SSB minus SSAB. That is what we have written is by subtraction we will get this. And mean sum of squares, S square E is equal to SSE by 3 into R minus 1. Okay, at the end the total degrees of freedom only written here 4R minus 1. Total sum of the squares is also to be calculated. Total sum of squares, TSS. Okay, so this is what ANOVA table for 2 square factorial experimental design by using RBD. It is going to be calculated in RBD with R replicates, randomized block design. Okay, and the comparison and conclusion. This is another crucial point you have to write clearly. The statistics which we consider FA, FB, FAB follows central F distribution with 1, 3 into R minus 1 degrees of freedom. Each with 1, 3 into R minus 1 degrees of freedom. Our intention is to calculate 3 particular statistics, particularly FA, FB, FAB. The F ratio is going to be calculated for 3 particular effects: main effect A, main effect B, interaction effect AB. To test any factorial effect, if the calculated F is greater than the tabulated value of F at 1, 3 into R minus 1 degrees of freedom and at specified level of significance alpha, then null hypothesis H naught of the corresponding factorial effect is rejected. If it is greater than, then H naught is rejected. Otherwise, H naught is going to be accepted. This is what we have to write in the comparison and conclusion. Hope you understand. This is what the entire statistical analysis of 2 square factorial experimental design. This is the statistical analysis of 2 square factorial design. Hope you understand. Thank you.